All right, today we're diving into one of my all-time favorite brain teasers. This is one of those puzzles that when you first hear it, it sounds, well, it sounds impossible, but it has this beautiful, super simple secret solution hiding in plain sight. So let's just jump right in.
So here's the deal. I want you to really try and crack this one right along with me. But hey, a little heads up. The path that seems most obvious, it's probably not the one you want to take. You ready for this?
Okay, let's set the stage. Imagine this. You've got two trains, right? And they're on the same track, hurtling towards each other. And caught in the middle, one very, very busy bee. So let's get the numbers straight. You've got train A chugging along at 50 kilometers per hour. Then you've got train B coming from the other direction a little faster at 70 kilometers per hour. When this whole thing starts, they're exactly 100 kilometers apart. And our little bee, our hero, it's zipping through the air at a steady 80 kilometers per hour. Got it? Good. Now this is where your brain might start to hurt a little. The bee starts right on the front of train A and takes off, flying straight towards train B. The second, and I mean the very second, it touches train B, it flips around, no hesitation, and flies right back towards train A. It just keeps doing this, back and forth and back and forth, this relentless shuttle run between the two trains, until they smash into each other. So the big question is this. After all that crazy, frantic flying, what is the total distance our little bee covers before it's all over? How far did it actually fly?
Okay, so let's talk about the first instinct, the way pretty much everyone, myself included, tries to solve this at first. It seems totally logical, right? But trust me, this path is a trap. It's designed to lead you into a mathematical rabbit hole.
So you'd think, okay, I'll just calculate the bee's first trip from train A to train B. Simple enough. Oh, wait. While the bee was flying, both trains moved closer together. So now the distance is shorter, so you have to calculate their new positions. Okay, now calculate the bee's trip back to train A. But wait, the trains moved again. The gap is even smaller. You see where this is going? You'd have to do this an infinite number of times. Yeah, for the math nerds out there, what you're looking at is something called an infinite geometric series. And sure, you could solve it that way if you're a math genius with a lot of time on your hands. But it's super complicated. Honestly, it's meant to make you just throw your hands up and say, "This is impossible!"
It really feels like you've hit a brick wall, doesn't it? But what if this whole time we've been asking the wrong question? What if there's a sneaky, elegant, almost laughably simple way to solve this? And here it is. This is the big pivot. This is where we change the game completely just by looking at it differently. You ready for this? The secret to solving this puzzle is to just forget about the bee. Yeah, I know, a puzzle about a bee, and the first step is to ignore it. Just push the bee out of your mind for a second. Let's pretend it's not even there.
Okay, this right here is the golden ticket. Think about it. When does the bee start flying? The moment the trains start moving. And when does it stop flying? The exact instant the trains collide. So, the total amount of time the bee is in the air is exactly the same as the total amount of time the trains are moving before they crash. The two times are linked. They're identical. And just like that, the whole problem changes. We don't care about the bee's crazy zigzag path anymore. Who cares? All we need to know is, how long was it flying? And since its flight time is the same as the train's travel time, the real question, the only question we need to answer is, how long until those two trains collide? So let's get into the beautiful, simple math. What once looked like an infinite headache is about to become a piece of cake. So there's this really useful idea in physics called relative speed. Basically, since these two trains are heading straight for each other, to figure out how fast that 100-kilometer gap is closing, you just add their two speeds together. Simple as that. So we take train A's 50 kilometers an hour, add train B's 70 kilometers an hour, and boom. Their combined speed, their relative speed, is 120 kilometers per hour. Every hour that passes, they close 120 kilometers of the distance between them. Okay, now we just need some really basic grade school math. You remember this one. Time equals distance divided by speed, right? So we take the total distance, which is 100 kilometers, and we divide it by their combined speed, 120 kilometers per hour. And what do we get? We get 100 over 120, which simplifies down to 5/6 of an hour. And what's 5/6 of an hour? Well, an hour is 60 minutes, so that's 50 minutes. That's it. The trains will collide in exactly 50 minutes.
And because we know the bee flies for that exact same amount of time, we now know the bee was in the air for 50 minutes.
All right, we have the key. We have the time. 50 minutes. Now, we can bring our little bee back into the picture for the final easy step.
It's that same simple formula again, just shuffled around. Distance equals speed times time. We know the bee's speed, right? A constant 80 kilometers per hour. And we just figured out its total time in the air, which was 5/6 of an hour. So all we got to do is multiply those two numbers together.
And the answer is about 66.67 kilometers. That's it. That's the total distance the bee flew. No crazy infinite calculations, no headaches, just a simple, beautiful bit of logic. Isn't that cool? So what's the big takeaway here? Because this puzzle is about so much more than trains and bees. It's really a masterclass in how to think about problems.
You see, it all comes down to this. The trick was never about solving the super complicated problem we saw at first. It was about realizing there was a much, much simpler problem hiding underneath it all. Finding the time was the secret key that unlocked everything.
So let's just put them side by side. The hard way? You get totally bogged down trying to calculate every single tiny flight of the bee, which goes on forever. It's a nightmare. The smart way? You just take a step back, change your perspective, and realize the only thing that matters is that one single variable, time. It's a total game changer.
And that kind of makes you wonder, right? How many other impossible problems in our own lives are only impossible because we're focusing on the wrong thing? We get so obsessed with the bee's complicated path that we miss the simple clock ticking right in front of us. What could you solve if you just took a second to find the real question?